Hello and welcome back to Adam's Workshop. Today, thanks to Kaiweets, we're going to review a smart multimeter that they were kind enough to send out to me. Comes in a nice hard shell case. Well, hard soft shell, hard enough to protect it but soft on the inside. This is the Kaiweets HT112B Bravo. It's a smart meter. I'll get in a little more into that here in a minute. It's a Cat 3 600 volt AC DC multimeter. It has current protection fuse protected with a 600 milliamp 250 volt fast fuse, which works, I know, because I did blow that one. More about that in a minute. And the sampling rate is approximately 3 times a second. It's a 6,000 count, has a maximum 6,000 count display on an LCD screen. And for overrange indication, it does display OL on the screen. It also displays a low battery function to let you know you're low on the battery. And polarity indication also displayed, and it's powered by two 3-volt CR2032 batteries. It does come in a nice case. I wish all meters came in a case. It also comes with your thermocouplers for your temperature probe. Comes with 4 CR232 batteries. Of course, I already put 2 of them in the meter. And it comes with a set of leads. Now, just good and bad news with the leads. Good news is they are modular, so obviously you can take them out of the meter. I know at least one other smart meter, I won't mention the name since I do not have it here to compare. It is connected full time where you cannot remove the leads. I anticipate those leads breaking. That's the good. Now the bad with the leads, let me unplug these ones. What I don't like about the leads is, as you can see, the leads that come with it are just so much smaller. Look at that. There you go. They're so much smaller, so that's a shame. I like being able to have a choice of what leads I want to use. I'm a fan of these Probe Masters here. You can go on their website, order what length you want. You can get different tips for them. Like these come with I order these separate screw-on banana clips. They have the gold plated probe tips. They're just great leads. They're not expensive. I want to say leads by themselves roughly 20 bucks, give or take a couple dollars. So anyway, with this smart meter, you are going to be limited to these leads only. With that said, if they do break, they are modular. You can remove them, and you can go on the Kaiweets website and order other ones. Up here, we have an indicator. You'll see when you power it on, it lights either green or red. The LCD display, a big display. I really love the size of that display. It's massive. In fact, I want to say it's larger than the display on the other full-size meter. Beautiful display. And we have the keys down here. There's only 4 of them, but some of them do share functions with, or keys with other functions. Here you have your power key. Long press it for about 2 seconds to turn it on. Go ahead and do that. After you turn it on, you have the smart manual mode key, which is right here. and once the meter's powered up, it defaults to the smart mode automatically. If you can see here, it's switching between voltage, AC/DC, resistance, and continuity. There we go. Now you can see it's switching between voltage, resistance, and continuity. You can press the key right here again one time to switch to manual function. As you see, it went up here to millivolts, and you can press it again to switch to the other functions. You see, each time I press through here, it goes to another function. When I get here to my microamps and milliamps for my current, it shows fuse. That's because I blew the fuse. Also, if you notice in the top right hand part of the screen here, no matter where I'm at on it, it says fuse up there to let me know that I blew the fuse. I'll get into why momentarily. You do have the select button. This is your function selection as well as a flashlight key. So when you have multiple functions, you can press this key to switch. So let's see. Say we go over here to non-contact voltage. You can see here non-contact voltage and live. Right now, if you notice here, we're in non-contact voltage. I could press the key, the select button, and now it's switched to live. Oh, can y'all see that? There we go. Press it again, non-contact, again live, back and forth. And if you press it for more than 2 seconds, you turn on the flashlight. So 1, 2, and flashlight turned on. Little LED light on the back. Press it again. I'm going to press and hold it again, and we'll see it's going to turn off. 1, 2 seconds, it turns off. That's a nice little case, guys. Just the size of this thing is nice. You can see my hand here. Here's my cell phone. It's the iPhone 7. It does have a case on it that is filthy since I'm always working on cars. Just to give you an idea of size. It is a little thicker. It's a little smaller overall, but it's a tiny bit thicker. And you can take the case off. Uh-oh, what did I do there? You can take the case off. There we go. Look how thin that is. Oh, on the screen, if you notice there are like a couple little, kind of looks like blemishes or whatever. That's because I have not peeled the film off that it comes with the protective film on here. I like leaving those on as long as I possibly can just to protect the screen. You notice on the back, this screw right here, one screw, take that out, open it up, and you'll have the 2 spots for your little fuse, or your fuses for your batteries. They'll actually fit in there pretty much just right there where you see those. And once you take that off, then you take these 4 off here. You can open the whole thing up and you can access the other fuse, which I'm going to need to do because I'm going to need to replace that fuse. And I believe it's a 600 milliamp 250 volt fast fuse, ceramic also, if I'm not mistaken. I believe it's a ceramic fuse similar to the one in the larger meter, the HT112B. Okay, next function here serves as 2 functions. It's the backlight and the data hold key. So you see, press and hold it for 2 seconds. Backlight comes on. That does help. That does help with actually seeing it. I do wish they went with the, I think it's, what is that called, an LCD reverse screen. I notice I'm starting to see those on different newer multimeters, and it just seems like those make it easier to see. Like I said, they did send me this, but I'm going to call it for what I really think of it. I'll give you all my general opinion of it and what I think at the end of the video. So you have your backlight, and then you also have, let's see, you also have hold. So You could press it and then it's going to freeze the frame and it's going to hold whatever measurements on the screen. And if you notice all the time throughout on the screen here, it has the temperature right here. And that is pretty much on it on most settings that you're on. Okay, right there it's showing duty cycle because we're on hertz for frequency, so it's going to show the frequency on the bottom and the duty cycle. And it's going to show the duty cycle on top. And you go through and then there's the temperature again. Now with that said, I live in the States, so I wish that showed Fahrenheit. It's in Celsius, and to my knowledge there's no way to change that. I wish they had, you know, where you can press or hold a certain button to be able to change that to Fahrenheit, but to my knowledge they don't have it. Here we have our current jack, our COM jack, and here's our measuring jack for everything except for current. Up here on the front, on the top, there is the non-contact voltage sensor. And then of course we already went over the flashlight. So now go ahead and let's just jump into some of the tests and we'll see how accurate it is. Okay, I'm going to take the safety tips off here, just so it's easier for me to connect these. Also, I think we'll use the mix sig here. Oh, I love this mix sig. This STO, just I'll point out real quick, has the color ring calculator. So if you have resistors and say it falls off of this where it has which size it is, if you don't know which size it is, say you just have a single one sitting around, you can look at the color code here, put it in, whether it's a 4 or 5 ring, put the color code in and it tells you what resistor it is. That's awesome. I had to use that a little bit ago, that's why I have it up there. Alright, we'll go to oscilloscope. We'll use this just to confirm the accuracy. Alright, so I'm going to make this quick. I'm just going to do a few tests on each one. I'm not going to go through all the way up to 32 volts and test every one. We'll just, wherever it stops is what we'll test at. 1.19, 1.19, and we're seeing 1.16. 1.16. Alright, so we'll just jump up a little more. 8.03, 02, 8.02, 8.02. And go to 2 volts per division there, and we're showing 7.96 on the mix sig. Let's go ahead and jump to 5 volts per division, jump that up to 15.28. You can see it does respond quick, 15.29, and we're at 15.3 on the mix sig. Alright, one last one, all the way up to the top. 30.22, we'll even add that in. 32 even. Down here, 32. And up top on the mix sig, we are at 32. 32.3, 32 even, 32.04. So checks out on DC voltage. So we'll get rid of this. There we go. And we'll stick them in the holes. And there we go, perfect. We got 120 AC. 120 AC true RMS and 60 hertz. So we got the hertz, AC voltage. It is saying true RMS. And also, if you notice, I forgot to mention, it does have the bar graph on the bottom here. There we go. It does have the bar graph on the bottom. 60 hertz, 120 volts, AC, and remember that was in Smart Meter too, so it shows, look, when I take it out, you can see it's bouncing around and it's looking for a signal. As soon as it gets a signal, it holds on to it. It goes to volts AC, 120, 60 hertz. Alright, so that was AC and DC voltage. Now let's check some, still in the auto smart feature, we'll check some resistance and continuity. Got a few things on a breadboard here that we can test. There we go. And if you notice, let me pull that off of there. If you notice, on the multimeter, you get a visual signal as well as the audible tone. Oh, you can't see that. There we go. You get the green light on the top on the meter. There we go. We get the green light on top. Tells us continuity. So we get a visual and audible. And of course it still shows the temperature there as well. Alright, and now on to resistance. Alright. Alright, for the resistance, anything less than 50 ohms, it's going to show in the low resistance for continuity. So here's a 10 ohm resistor. Look, it's pretty quick too. Get that in there where you can see. Just as soon as I touch it, it beeps. 10 ohms exactly. Visual, audio, and it's on continuity. Anything under 50 ohms. So there's 10 ohms. Here is 47 ohms. There's 47. And look, it's still on the continuity. 47 point, there's 47 even, 46.9. And then now you're going to see it jump. Now you're going to see it jump down to the resistance measurement, because this one here is 56 ohms. No audible sound. The green light does not come on. It just goes to resistance right here. Remember, it's still in the smart function this whole time. Just goes to resistance, shows your temperature, and then shows you your measurement. 55.8. It's a 56 ohm resistor. So I'll go 55.9, 55.9. So there you have it. Next we have, well, that was the millivolts. Alright, so now I went into manual mode. I'll show you how I did that. Alright, I was in the smart function, and in the smart function it's going to continuity. I want to go up here to millivolts, so I'm going to press the smart function and it moved right up to millivolts, as you can see. And that's millivolts AC and DC. See the negative sign? I do have my leads connected wrong to my power supply. We'll correct that real quick. And there you have 270 milliamps. 270, it's kind of fluctuating a little bit on both. 260 here now. We'll go up a little more. 390 millivolts. It's kind of fluctuating. 400, 403. It's kind of fluctuating a little bit. So there's our millivolts. Next on the meter, we have hertz. And just press our smart button to go there. And on the top, it's going to show the duty cycle. And on the bottom, it'll show the frequency. So now we'll go ahead and we'll connect up to a signal generator over here. Anyway, so we're gonna use that there, but I'm gonna keep you all tuned in over here to the meter, and I'll tell you what I'm doing with the generator. Hopefully we'll see it. Hopefully we'll see it on here. So 5 volts on the top here. 5 volts, 50% duty cycle, and 10 kilohertz. As you can see, it's 10,000. About 10,000 hertz. Since we're already on 10, we'll jump up to 30. 30 kilohertz. 40. Jump up to 80. There's 100. 140. Jeez. 200. You know, let's just jump to the next one. 300, 400, 800, 900. There's 1 megahertz. There's 1 megahertz, and let's just keep jumping up, see how high it'll go. Let's see what it's rated at. So hertz position, percentage position range 10 hertz to 10 megahertz. Response, y'all can see this, overload protection. AC voltage position range 10 hertz to 2 kilohertz. So let's see, it's saying 10 megahertz. It's 2, 3, 4, 5, 7. There's 10 right there, 10 megahertz. 11, 12, 13, still have 50% duty cycle. 15, 16, 17, 18. Geez, did I read that wrong? There's 19. There's 20, 21. Okay, there's 24, and it went out on us. So it looks like it capped out at 17, 18, 19, 20. So it looks like it goes up to 20 megahertz. Am I seeing that right? Right here? It says 10 hertz to 10 megahertz. Yeah, look here, 10 megahertz plus or minus 3% plus 5 right here. 10 megahertz. Oh shoot. 10 megahertz plus or minus 3% plus 5. I mean, it's right on. We're right on 20 megahertz exactly. And here on the screen, we're at 20 megahertz exactly at 50% duty cycle. Wow. So, unless I'm not seeing that right, it's going twice over what it says it limits at. So, absolutely no complaints there. That's awesome. Alright, what do we have next? Next we have capacitance. So, got a couple capacitors right here we could test real quick on our breadboard. There we go. We got 2 capacitors. This one here is 50 volt. Let's see what that is. I have to get out the old magnifying glass. 50 volt, 100 microfarads, and the smaller one is 50 volts, also 10 microfarads. So 100, we got 110. Alright, let's see how quick it does it, and let's see if it's accurate. Here we go, starting right now. And there it is. 100 microfarads. Still shows the temperature 25.9 degrees Celsius. Not sure what that is in Fahrenheit. Like I said, I live in the U.S. I wish we can change that to Fahrenheit. Alright, so now we'll go to the other one that is 10 microfarads, and here we go. 9.77. So I'm good with that. I'll zoom in a little so y'all can see the measurements. Maybe I'll raise that up. There we go. Alright. 9.7 microfarads. And here's the 100 again. And 99.9 showed 100 the first time. So not bad. Pretty quick. I've definitely seen others that take much longer than that. Alright. Next function is diodes. Diodes. Everybody loves the diodes, right? Everybody loves lighting up the LEDs, which are light emitting diodes, for those that did not know. You can see we got a few different colors, and we have a diode rectifier there. I guess we could do that one first. I meant to do that hold function when we were connected. Just show y'all real quick here the hold function. You can see on the power supply we're at 6.27. Here we're at 6.2. It was 2.7. It just went to 2.9. All right, so we can press right here. Man, is that clear? All right, we could press hold, and as you see right here, H pops up. So now it's going to hold our measurement. We can disconnect our leads from the power supply. Our leads are disconnected and still shows 6.9 or 6.29 volts. If you notice, so I'm at 30.22 on the power supply. If you notice on here, 30.24. And then if you notice on the bottom, there's that bar graph. And you can see 0, 0, 10, 20, 30 volts. So that's pretty neat. Showing DC. If I want, I could press the hold button again. It'll hold it. Again, we'll disconnect our leads. Yeah, we're still seeing our 30.24 volts. So that's pretty neat. I like that. Hit smart again, function. Did our capacitors. Now we'll go to our diode setting. First of all, let's see what our diode setting puts out. See how much voltage it puts out. We'll connect this one to this one. Wow, look at that. For this little meter, for its diode setting, it's putting out 3.9. What happened there? Oh, I see. Bad connection. What am I doing here? 3.9. What's going on? 3.93 volts. Alright, somewhere I do not have a good connection. There we go. 3.93. Every time I say it, it does it. 3.938 volts. Almost 4 volts. Why is it doing that? And we know we're going to light them all for 3.9 volts. In fact, I bought these LEDs online. These are not any of these, but just to give you an idea, you can see some of the voltage for these colors here. Like, look, red 2 to 2.4, blue 2.8 to 3.2, yellow 1.8 to 2.4 volts, and green 3 to 3.2 volts. Wow. So we know at 3.9 volts, we're going to light everything up, no problem whatsoever. Go back here in our function button, go to diode. still shows our temperature on top. And let's light up some of these. We'll start with the yellow. Oh, you know what? Let me kill some of these lights. There we go. Get the right mood going here. There's yellow, 1.9. No problem. Blue, no problem at 2.5. Green coming in. Green coming in at just, well, I saw over 3 for a second. What happened there? 2.3. Red, it's usually pretty low, 1.8. One thing I noticed when you actually check a diode, here's a diode rectifier, you're going to get an audible tone from here. Listen. And it's right away. You hear that beep? Look, as soon as I touch it, right there. Look how quick that grabs it too. Grabs that measurement quick. So that's 604 millivolts. 603 millivolts. So that way, if you can't see your screen and you're doing a test, and then all you can do is listen to see if it's good. There you have it. You know what? We do have an RGB, so we might as well check it out too. So if y'all don't know, on LEDs, just give you an idea here, the shorter of these two legs coming out is known as the cathode. Now correct me if I'm wrong here, guys. The shorter one is the cathode, which is your ground. The longer one is, if I remember correctly, anode is the anode, which is your positive. Also, on your ground side, right here, it's gonna be flat. I'm not getting it good. It's gonna be flat right there. Like the rest of this all the way around, it's all round and smooth, but on the ground side, on the cathode side, it's gonna be flat right there. That way, that's how you know which one is which as far as positive and ground. And on these RGBs, red, green, and blue bulbs, the second one to the left, the longer one, that's your ground, and then these are your different colors. I want to say it's red, blue, green. I don't know, let's find out. So first one, yeah, so the one on the left is your red. The ground's going to stay in the same spot. Ground's going to stay in the same spot. I'm going to turn our light on here. And there's the green at 2.28. And then there's the blue at 2.25. And the red again at 1.7. So that's pretty neat. And all we would have next would be our microamps and our milliamps. Unfortunately, guys, alright, this is what happened. I was sitting here, I had it connected to the power supply. I was doing something, but at the same time, I was on FaceTime with my daughter trying to explain to her how to do something else on her end of the phone. Now, these only rated to 600 milliamps for your current. 600 milliamps. And like I said, if you watched my video on the power supply, the one thing I hate about it is it's kind of hard to stop at a particular number. You know, like if I want to go to 650, look at that. Look how much it just jumps everywhere. Now that's your course. You do have a fine one right here. So once you get close in the vicinity, see where you can see it. Then, well, see, I just barely touched that one. It jumped off again. So anyway, what happened is I was trying to get it close. I said I was talking on FaceTime and I thought I was turning the fine one. I was not looking at the screen. I was looking at my phone on FaceTime. Turns out I was turning up the coarse one, and I think I heard this beeping at me, like it's beeping now. You hear that? I think I heard it beep, and I want to say I even looked at the screen and I want to say it flashed or something, but I was on the phone, I was talking on FaceTime. I didn't realize what was happening, and then before I knew it, pop, it said fuse across here, and also on the top here it shows fuse. But with that said, I will tell you it was measuring correctly before I blew the fuse. But this is nice because you do get to see what happens when you blow the fuse. Whereas on its big brother, when I blew the fuse on this one, matter of fact, this one still has the blown fuse. It doesn't tell you. Look, it doesn't tell you that the fuse is blown, right? The only way I knew for sure, well, one, it wasn't measuring, but two, when I opened it up and I pulled the fuse out, that's when I knew for sure. So I do like that feature. I do like that it shows fuse on the top right. It spells out fuse when you're in those function areas, but when you go out to another one, it shows fuse up in the top right corner there. Another thing that's cool, real quick, go back into the current section. If oh, it may not do it because the fuse is blown. Yeah, it's not doing it because the fuse is blown. So basically, if I'm plugged in here to the voltage side and I move the function switch over here to either micro or milliamps, it's going to spell out leads, L-E-A-D, to let me know that I'm plugged in the wrong one. Or if I'm on a different area and I plug this one into the current, well, see there, at least that one still works. So look, I'm over here, I'm in the smart options, and I'm going to plug in to the current jack, and as soon as I do, it's going to switch my function indicator over to current. It switched it to microamps. So that's pretty neat. That way, make sure you're plugged into the right one. Alright, last but not least, we have non-contact voltage and live voltage. I gotta tell you, for this non-contact voltage, check this out, guys. This thing is really sensitive. Watch. Alright. Oh, it won't let me move off. See, look at that. I'm trying to move it off. I'm trying to move it to the next one here to non-contact. It'll let me move to milliamps, but it won't let me move off of the current setting because I'm still plugged into the current jack. As soon as I plug into there, now it lets me go. Again, it shows a temperature right there. And we have two options. Man, my light is freaking out here. It's kind of crackling and whatnot. Huh. Okay, anyway. So you can see right now we have non-contact voltage. And so let's test it out. There's a cable that's plugged in to charge my iPhone. So the green light means it's, let me see, let me tell you exactly what it says on here. If the meter senses a weak AC voltage, the green indicator light will be on, the buzzer will beep slowly and display an L. So when it senses weak AC voltage, the light is green and the buzzer beeps slowly. So there's green. I don't want to get too close here. There's green. You hear it beeping slowly. and then if the meter senses strong AC voltage, the red indicator light will be on and the buzzer will be fast, displaying an F. Oh yeah, there's green. You notice there's an L for low voltage or low signal. And then as we get closer, turns to an H, turns red, and listen how fast that's beeping. Wow, this thing's pretty sensitive. In fact, I want to say this one is more sensitive than its bigger brother, than that other Kaiweets meter, the larger one. Yeah, so that's pretty neat. I like that. All right, and next we're going to do the live function. So we'll hit select, and this is going to take us from non-contact voltage to live, and we're going to plug in our red lead, and just our red lead. I do want to mention, when you plug these into here, these things are not coming out. I mean, you really got to pull on them to get out. It is a really tight fit. Yeah, when they're on here, I mean, I don't even know if I could do that with one hand. Yeah, if I really work at it, I can get it out with one hand, but it snaps in there. Look at that. That is not coming off. Alright guys, so that sums up all of its functions. I think I pretty much covered everything. This video, as they always do, go way longer than I plan on. I always tell myself I'm going to do like a 10-15 minute quick video. Before I know it, freaking hour has gone by. Anyway, final thoughts. My final thoughts. The leads, I know they had, I'm assuming they just had to make them smaller to fit into the jacks because it's such a small meter. I wish they were normal size so I can choose whether I want to use Probe Master or Fluke or whatever leads, suit you. Other than that, I do like that they unplug. I know some other smart meters, they're permanently attached. Size, you can't beat it. I mean, that's an awesome little size, fits perfect in your hand. It's a cool looking case. I used to have a case that looked very similar to that for, I think, my first iPhone. Anyway, the size I think is great, but at the same time, that's what's going to kill it. Because it's so small, you just can't fit in it what you can fit in something larger like this, like its big brother. This is the HT112 Alpha, and because you got 600 volts AC DC, you only have 600 milliamps for testing your current. I do mostly automotive diagnostics. That's not going to cut it. I would blow that fuse probably constantly. Just wouldn't work for me. If I had no multimeters and I was looking to buy my first multimeter or something I'm going to use all the time as my main meter, would this be it? No, it wouldn't. It would not be it. Now this one, on the other hand, yeah, I would buy this for my main meter if it was the only one. Does everything this one does and then some more. But no, I would not buy this as my only meter. Now, if I already have another multimeter and I just want an extra one, I want one maybe to keep in the car, in the glove box, that's not going to take up room. I want one to toss in, I don't know, a briefcase, my front pocket of my flannel or my jacket. Hell, this is so small you could actually leave it in like an inside pocket of a coat. Would I buy for that? Absolutely. All the tests I did, it's right on. It's on the money for voltage, AC and DC, for resistance, continuity, all of it, diodes, capacitors, everything. As far as its testing capabilities, what it says it'll do, it does, and it does accurately. With that said, like I said, the size is so cool, but it also hurts it. And this is probably the main reason right here, is battery life. You know, it takes 2 of these CR2032 battery cells, and I mean, honestly, how long are those going to last? Especially if you're turning that light on. And with the screen, the LCD screen, I'll be honest, a lot of times I do need to turn that light on to be able to see the screen better. Like I said, I wish they'd do that reverse LED or whatever, LCD, I keep saying LED, LCD, or whatever they're doing on those new multimeters I've seen, where it just makes it stand out better. But yeah, that's just not going to be enough battery life, I don't think, to use as a daily meter. But for a backup or a second meter, or one just like I said to keep in a car, to take with you somewhere just to have, yeah, it's an awesome meter. It's really cool. It's really neat. I like the meter. I'm sure I'll use it plenty. I'll probably put it in my glove box in my car or my truck and leave it there, so I always have one. Would I buy it? Would I recommend to somebody to buy it? Yeah, absolutely. As their main meter for working, no, not as your main meter, but as a second or a backup, yeah, absolutely. It's an awesome little meter. It's just not going to have the battery life, I don't think, to use day-to-day, all-day use. I think it's awesome. It comes with the case. I did not use the thermocoupler in this video. It works. I tried it out. I won't torture y'all, make y'all watch another test. But you can see on here it's showing the temperature all the time. Your what is that, relative temperature? What is that? What's that word I'm not thinking of? The existing temperature around us right now. I'm drawing a blank. Anyway, it's a good meter. I like it. It's really neat. Go out and get you one. Real quick, I did not show what the 6,000 count was, what that means. I want you all to see this. You see right now we have 1 digit, and then we have the decimal, and then we have 3 digits to the right of the decimal. And we're going to have that on all the numbers basically under 6. You see, it's like that all the way down. But then when we go up, try and get this close as I can without going over. Alright, look, it's a 6,000 count meter, so it should switch when we hit 6. 6. Oh, there it goes. Right at 6. Alright, bam. So we're at 587. 599. So right at 6 it switches. Some of them you got to go over a little bit. So that's actually right on the money. Anyway, that was just some bonus footage. In case y'all didn't know what a 6,000 count is, you have 6,000 count, you have 4,000. I think you have 10 and 20,000 counts. All different options to give you more or less decimal points. And that's going to conclude our video for the Kaiweets HT112 Bravo. Pick yourself one up. It's a neat little meter to have. Again, I would not buy it as my main go-to work meter, but I'd definitely buy it for a second meter, a backup meter, or a meter to keep in the car or to take with you if you don't have a lot of room and you just want to toss it in your pocket. Alright guys, we'll see you on the next one. This is Adam's Workshop, and we are signing off. We'll see you next time. Thanks for stopping by.